are here at CERN, which is one of the most important laboratories in the world, but in particular is important for IMAPP students since CERN is really important in the partner circuit of the master. To visit the Scoyotron, which was basically the first accelerator here at CERN, which was really important for many discoveries, in particular for the pion decays, which highlighted a lot of important things for the weak interactions of a standard model of particle physics.
Important decisions are taken in the first sessions of the new council. Geneva is chosen as the seat because of its central location in Europe and its international tradition. Theory predicted that a direct decay into an electron and a neutrino should happen, but this had never been observed. Scoyotron accelerates its last beams in December 1990.
Then we moved to the point 1, where the Atlas detector is located. We have visited the lab in the surface since the underground part was inaccessible for us at that day. Then in the morning we went to visit LHCB, which is one of the main experiments of the CERN accelerator complex.
You are in the meeting room of the operation of LHCB. 2 times per week we meet together to coordinate the activity of the data taking, to understand which are the problems. So the run chief present the status of the machines, the run chief is in charge of attending the meeting with the LHC, and to report to the experiments what will be during the week the activities of the machine.
We are here in the control room of the LHCB experiment, one of the 4 main experiments of LHC at CERN that is mainly focused on B physics and charm physics. is the place where we control the full experiment. Basically, here we can see a lot of monitors, a lot of screens, and the people from the CERN, from our collaboration, take data, they monitor the things, they check that everything works. This is the main panel where we receive information from LHC control room. They say what happens. Right now is in shutdown, so there are no beams, and they provide comments. Once they start ramping up and filling the LHC, we receive information until we reach stable beams. Stable beams means we can start doing operations, we can start taking data, we can turn on the voltage and do all the preparatory stuff to effectively take data. We are very connected with our experiment because it's the same machine, so the LHC control room have to take care of the full experiment.
Basically, in this room, we try to show how each particle produced in LHCB travels through the detector and what signals it leaves there, and how each subdetector contributes to the data taking of the full detector. We have all the particles flying, and the first stages it meets is the velo detector, which tries to reconstruct the first flight of the particle. Basically, we have the interaction point, the particles get produced, fly, and then they decay. So we try to reconstruct the secondary vertices after the particle has decayed. From there, it reaches the first reach detector, which gives us some information about the identity of the particle, and then it reaches the UT tracker. Then the particles, since are electrically charged, get deviated by the magnetic field of the magnet, and then reach the second stage of tracking, which is in the Sci-Fi tracker. And once again they reach another reach detector, which is the reach 2, which gives the information about particles with an higher momentum compared to those that were seen in the first reach detector. After that we reach the calorimetric system, which basically tells us how much energy was in the particles that we were investigating. And finally our particle reaches the final stage of the detector, which are the muon chambers. And the muon chambers see the muons, since they are the particles with the highest penetrating power.
LHC is not just one single accelerator, but is a complex accelerator, starting from a LINAC, then going to PS and then SPS, that are older accelerator but still in place. Even LHC, that is the largest one that we are using now, will in the future maybe used as a booster for future experiment with higher energy.
The day after, we visited the CMS experiment. The acronym suggests is a compact muon solenoid, means that it's much more compact with respect to the Atlas. We had the opportunity to go down with the elevator to see the real structure of the experiment. physics that it's interested in is exactly the same of Atlas. The dimensions are smaller, but it's heavier, so it uses different technologies, but basically it has the same purposes in terms of physics. This is really important since when you have two experiments that perform the same kind of searches, each one can cross-check the other. Okay, so you can claim for a discovery only if both of them have found something. This is what happened, for instance, in 2012 with the Higgs boson discovery. Final part of the visit was AMS control center. So we moved in space actually, since AMS is a detector which is located on the International Space Station, which is orbiting 400 kilometers around the Earth. And here at CERN we have the main control center. To understand how it works, and then we had a lot of nice introduction to the space science. Then we moved to IT data center, where most of the data converge. So we visited the main blocks of the IT center, and we also had visited the computer farm, which processes the data coming from the experiments.
We are inside the Meran data center of CERN. This is where all the data from the different experiments are sent after they have been processed by the first level triggers. This data center currently holds around 1 exabyte of data, which is 1000 petabytes. And these data are then they're stored for long-term storage, and they are then exchanged across the other kind of facilities that are collaborating with CERN, so the so-called WLCG, Worldwide LHC Computing Grid, which helps CERN to process this kind of data, reconstruct the different events. Additionally, the technology that CERN has developed to exchange data across the different sites has also helped into the development of the so-called World Wide Web from CERN Tim Berners-Lee, that in his research proposed this new idea to exchange different documentation and data across different facilities.